Good morning, I'm here to talk to you about light dependent resistors, or LDRs for short, and thermistors. Now both of these are resistors that behave in different ways depending on what is affecting it. So light dependent resistors are affected by light and thermistors are affected by heat. Okay, so you do need to know the symbol for an LDR. You draw a normal resistor, draw two arrows pointing towards it that represents light, and then you draw a circle around it. Now traditionally I wouldn't have bothered drawing a circle around it, but the AQA specification seems to think that you'd need to. Okay, a thermistor is the resistor symbol again, and you draw this thing that looks like a hockey stick through it. Okay, so both of these free up electrons when they are affected by their thing or property. So an LDR, when light shines on that frees up additional electrons in the circuit, and this one, the thermistor, when that is heated up, that frees up extra electrons in the circuit, which means that the resistance goes down. So for an LDR, if we have light shining on it and we have the resistance on that axis, then as the light increases, the resistance decreases. It would be the same or for a thermistor. So if the temperature goes up, the resistance, it goes down. Right, okay, so what are the practical uses of these things? Okay, if we've got a circuit where we have got a Bunsen burner underneath, you've got your tripod, you've got your heatproof mat, you've got your gauze, you've got a beaker full of water, and what we're doing is we are heating up a thermistor and we're measuring the resistance using an ohm meter there. And what we would find is that resistance would decrease as the temperature goes up. Now, this is used in a thermostat, so something that is temperature dependent that controls the central heating in a home. And the setup for this is a potential divider circuit. Now, don't panic. This is higher tier content, it's a higher tier concept, and it's likely to come up at the grade 9 level, but there's nothing particularly difficult about this. So let's say we have got a circuit for a thermostat. This is a fixed resistor. In other words, the value of the resistance doesn't change. This is a variable resistor in that, sorry to mislead you, it's a thermistor, but the resistance would vary. Okay, so the resistance for this would go up and down, this one wouldn't change. Okay, now we know that voltage equals current times by resistance, which means that voltage is proportional to resistance. So if the resistance goes up, then the voltage will also go up. So let's say that this has got an equal share of voltage across the two. Okay, now if this gets cold, this would go up, and that will make up a value of 6 volts. Therefore, the resistance, okay, with this, which is the same, would mean that this gets a lower voltage share, okay, because this one has taken more voltage in the circuit, so the voltage across this would drop. It is this drop in voltage across this fixed resistor which would cause a thermostat to kick in. Okay, if you get a question related to a potential divider, then you might be able to figure it out with common sense, but just in case, you can calculate the missing resistance or the missing voltage by using the ratio V1 over V2 is equal to R1 over R2. That is not on the specification, okay? However, it may be part of the 25% unseen content, and you could be expected to figure that out for yourself. Okay, all right, hope you're all well. Thank you very much.